Hi everyone, this video is an exercise 9C question 5. So this question is on the ambiguous case of the sine rule, and I'm going to explain that in more detail once we start the question. So we basically have two triangles ABC such that the question has already hinted us, and sometimes they don't. So in this case, since they have said there are two triangles, then they're basically referring to the fact that there are two possibilities um, of the value of one of the angles of the triangle. Anyway, so we have two triangles such that AB is 4.5 centimeters and BC is 6.8 centimeters, and angle ACB is 30 degrees. So we want to work out the value of the largest angle in each of the triangles. So first of all, let's draw a triangle here, and this is one of the triangles, obviously. So we have this triangle, and so yeah, I think it doesn't get better than this. So in this case, let's label this as ABC like this. Now, in this case, we know that AB is 4.5 centimeters, BC is 6.8 centimeters, and ACB is 30 degrees. So we want to work out the value of the largest angle in each of the triangles. So in this case, B is the largest angle, and that's something that is obvious. But since the value of C is constant, and we know because this angle is 30 degrees, there can also be another possibility that A being the largest angle of the triangle. So that's why we have basically two cases, and therefore this is the ambiguous case of the sine rule, because we essentially solve this by sine rule. Now, in this case, we can start by basically finding the value of angle A first. So we have sine 30 over 4.5 is equal to sine A over 6.8. And now we rearrange this. So here is sine 30 times 6.8 over 4.5. And obviously we need to take the sine inverse of the right hand side. Now there are two possibilities. So you need to remember a fact that sine theta in general is equal to sine 180 degrees minus theta. So this is a fact. And this is the main reason that we sometimes deal with the ambiguous case of the sine rule. Because in some triangles, or in some questions basically, either let's say one of the values of the degree is 40, so one of the possible angles of the triangle is 40 degrees, but also 140 degrees is also possible. So remember, the sum of the interior angles must add up to 180 degrees. And sometimes based on the combinations, both cases are possible. So that's why we have this ambiguous case. And again, in the question, it's explicitly, or actually just they gave us a hint about that. So yeah, all we need to do now is that when we take the sine inverse, so the value of A is equal to 49.07 degrees. Also, another case is that, remember, when we do 180 minus that to get the larger angle, and in that case we get 130.926 degrees. So I'm keeping them as exact values because we need them for the final step. So there are basically two possibilities for angle A, and that means there will be two possibilities for angle B, right? So when A is equal to 49.07 degrees, then obviously B is the largest angle. That's just because B is equal to 180 minus 30 plus 49 plus 0.7, where remember that 30 is just the value of angle C. And in this case, B is the largest angle because that is equal to 101 degrees to three significant figures. But in the case that A is equal to 130 degrees, then B is basically is not going to be the largest angle, so we can work that out. But I think it's very clear that B won't be the largest angle because as you can see, we have 180 minus 130.6 plus 30. So in that case, B is equal to 19.123 significant figures. So yeah, in the case that where A is equal to, this is case 2 and case 1. So in the first case, the largest angle is B, which is 101 degrees. So that's the first triangle. And in the second triangle, the largest angle is A with this value.